Back there on the back are some extra pages. And we're still missing something. I'm sure I have some more over here on this side. Get your, it's legal paper. That's what it is. It's legal paper. So we're gonna get our legal paper out. We're gonna lay it flat or horizontally, not vertically, if that, when you call it that. And we're going to go ahead and get both sides and we're gonna fold them in. It's like a book. It's gonna open up like a, I don't know, what's the window? It's like a window. French doors, I don't know, whatever you wanna call it. So now it opens up like this. You know, right, that all of our foldables are grapes. So now it opens up like this. Now on one side, I'm gonna go ahead and I'm going to write covalent bonding, and the other side I'm gonna write ionic bonding. And the reason why is because everything on this side is gonna be for that ion covalent, and everything on this side is gonna be ionic. So let me go ahead and get, I'm just gonna get whatever pen I've got red. Covalent bonding. Okay, and then the other side is going to be ionic bonding. So covalent bonding, I'm going to just turn this around so I can write out ionic bonding. Don't tell me. Who is it? It is going off, isn't it? Yep. Yep. And this wasn't a scheduled fire drill. Oh, nope. That's the other building. Yes. Right. It's next door, so we're good. All right, so I'm going to go back to covalent bonding. And on covalent bonding, covalent, how do I know it's covalent? It's a nonmetal plus a nonmetal. And what do they do when we do the drawing? They do this one thing, and they all do the same thing. They share valence electrons. So all covalent bonding, all of them are going to share valence electrons. Okay? How do they share? They share with a line. The line indicates sharing. Now, ionic bonding is special because it's a non-metal, like a metal, plus a non-metal, right? But don't forget though, it can have polyatomics, it could be polyatomic, it could be polyatomic non-metal, okay? But they transfer. Valence electrons, okay? They say, here you go. I've got this extra one. I don't want it no more. You take it. Okay, I'll accept it. And when they transfer, the metal gives up or donates its valence electrons to the nonmetal. And he's the guy who accepts it. I'll take it. I'll take your leftovers. Whatever you got, go ahead. I'll take it. That's what he says. Okay, so let me go back. That helps a little bit. I'm going to covalent bondings are nonmetals plus nonmetals share valence electrons. They do that with lines. That's how they indicate it, with lines. Ionic bonding is a metal plus a nonmetal, or a metal plus a polyatomic, polyatomic plus a polyatomic, polyatomic plus a nonmetal. But the metal gives up or donates its valence electrons to the nonmetals. Now let's go ahead and let's, before you walk away or before you finish, please make sure you put your name on it. before we're done with this. Okay. So the covalent side, let's open up the covalent side. A couple of things that we know about covalent bonding is that it's going to be a non-metal, let's say non-metal. This is key. Do not crisscross. And let's stop for a moment. This might sound, oh, we're crisscrossing. Well, we weren't crisscrossing covalent bonding. We're crisscrossing all those other ionic bonds. Well, what do you mean? If you go back and think about the naming, remember, if the first element had 4 behind it, and the second element had, 2 behind it, then those numbers, we never crisscrossed them because those numbers, those little tiny numbers, went with those elements. There was no crisscrossing that was involved. Now, they do share electrons. But they do not reduce. For example, if I've got C2, H2, oops, I'm going to my crease. I better. C2, H2 ends up being C2, H2. Okay? Don't pass up your crease because you're going to have something in front of it. Next thing here, they have the lowest melting point. They also have the weakest of all the bonds. They can be a solid, liquid, or a gas. They, when dissolved, this is important for mapping, in H2O, it does not break apart. Because it does not break apart, then it does not conduct, this is important for lab day, electricity. Okay? Now, when we do our drawings for them, for an example, if I have a hydrogen who has one element, or sorry, one valence electron, and I have a fluorine who's in group 17, 1, 2, 3, 4, 5, 6, 7, I do not draw arrows. That's a no. I don't say this. That's a no. I don't just do a little circle around it. That's a no. What I do, how I do draw them, is I say H line F 1, 2, 3, 4, 5, 6, and that's a yes. This drawing is acceptable and okay. Drawing a circle around the 2 electrons is not okay. Drawing the arrow to show that, hey, he's gonna go give him, he doesn't give, he shares. And how do I indicate sharing? Through a line. And this line right here means sharing the electrons. And between these types of bonding, they can have what we call nonpolar or polar. And so if it's a nonpolar between those two bonds, that means that they equally share, supposed to be 1L, huh? Electrons. I put 2, sorry. If it's a polar bond, which they could have polar bonds, even though it's covalent, they are unequally share electrons. And that's because one element is more electronegative. And that makes him stronger, and he can pull the electrons closer towards him. Okay? So that's going on that side. Now let's go ahead and open up the ionic bond, but don't write over the crease, because we need that crease. So on ionic bonding, here's a couple of things that are important that we need to know. This is going to be a, cannot see with all this fog in my glasses, so. Oh, there, that's easier to tell. I'm gonna have a metal and a non-metal. I can have a metal plus a polyatomic. I can have a poly plus a poly. I can have a polyatomic plus a non-metal. All of those are considered to be ionic bonding. Now, one thing that's important here when it comes to ionic bonding is that, yes, they do reduce. For an example, Mg2O2 is going to become MgO because it's reduced. And because there's reducing going, then we can't do prefixes. I mean, is it a mono or is it a di? I mean, 2 to 1, we can't do prefixes. And that's the reason why there's no prefixes. Okay? We also make sure that we must crisscross charges. And it doesn't matter whether we're crisscrossing down or whether we're crisscrossing up, backwards. Some kind of crisscrossing is going to occur. Alrighty? The other thing that we need to know is that they transfer electrons. They donate and accept. They give up, they take in. The bonding occurs between the ions, which is the positive and the negative charges. And what happens here is that they attract. That's where the bonding occurs, is between the ionic charges that they have, the plus and the negative, like a magnet, and then they attract towards each other. Now, when we're drawing them out, for an example, we can do in A, sodium. Sodium is in group 1, so he has 1 valence electron. Cl, chlorine, is in group 17. 1, 2, 3, 4, 5, 6, 7. And we can get this arrow and bring it over here. And that's a yes. That's an acceptable drawing. Another type of acceptable drawing is going to be, we're going to go back to the NaCl. NaCl, and use brackets. And I can do a +1 over here, and I can do a bracket over here, and I can do a negative. Most of the time, because instead of doing a -7, because it does -7 electrons, a lot of times you might see it like this. And you might even see one over here, and you may not see a +1, you just might see the positive and the negative, and that's okay as well. But when we get to group 16 through 17, they just don't put 7 and 6 up here, we're just too, I don't know, too big of a number. That's also acceptable, yes. But if we did in A, C, L, 1, 2, 3, 4, 5, 6, that's a no. That's a no. Because the line indicates sharing, and this is ionic bonding, and there is no sharing going on. Now, a couple of things that that are in our notes is they have the highest melting points. That's good to know for lab day. They are the strongest of all the bonds compared to covalent. They tend to be brittle and crystals. Hard, brittle crystals, like table salt. At room temp. And are called salts. Okay? Solids. What was covalent bonding? Solid, liquid, or gas. These are solids. And when dissolved in H2O, important for lab day. The salt, or that solid, breaks apart into the ions and conducts electricity. Alrighty, so now those green papers that you have, just so that way you'll know in just a moment, they're actually going to go here in the middle. I don't know if they're cut exactly because I just chopped them all off. So hopefully my green papers fit in the middle. Okay. Now, not only am I going to fit them in the middle, but I'm actually going to cut them. And it's going to look like this. Here's last year's. Instead of using green, we'll use white cardstock. Here's the first one. Here's the second one. Here's the third one, and here's the back paper. So you were able to quickly see them and flip them up and say, it was just a lot. It's a little bit easier that way. So let's go ahead and start off with, on the actual white paper, I'm going to label that over here, acids. Now, what I'm going to do is I'm going to get my green paper and put it over it, and I'm going to decide, well, I need to cut it so I can see the word acids. Does that make sense? So now, let's go ahead and cut it, because I'm going to tape it at the top, but I need to cut this so that way I can see the word acids. There it is. I can see the acids. Perfectly good. Once I see that, I'm personally going to tape it down and get this sucker stuck on here so that way it's not moving around on me. flips up, flips down, and I can see the word acids. Now on that green paper, we're going to write degrees. Shapes and drawings. And polar or non-polar. I'm going to do the same thing. I'm going to get another green paper. I'm going to place it on top, and I need to cut it out so that way I can see those words. So I'm going to put my second green paper on top. Just going to pick it up a little bit so I can see where I'm going to cut at. And there we go. Now I can see the words, and I'm going to go ahead and take that in. Again. The next one you're going to write is covalent / ionic practice. Covalent / ionic practice. And you know what to do with the next green paper, right? We're going to set the next green paper on top. We're going to cut it so we can see those words. We're going to tape it down so that way it's nice and secure. And remember, if y'all need some extra ones, I've got plenty in the back of the room. Okay, I've got more green paper in the back of the room. I've got more white papers in the back of the room. So let's place this on top. And at the end, if you want to take a picture of this, you're more than welcome to. Cut that so you can see it. There we go, I can see the words. Tape them together. That side. I'm going to tape the inside too, just to make sure that it doesn't come apart. Something's good. We're not going to write anything at the bottom of this page, okay? We're going to write it at the top of it. So at the top of the top green page, we're going to say naming / bonding. Talking about here. Now when we're naming, we've got those covalent bonds and they have these weird prefixes. So I'm going to go around my prefix paper. I'm going to cut it out like nice and neat, like a little rectangle. And that's going to be taped over here at the bottom of the top green page. At the bottom of the top green page. Now you can see that there's blanks. 1, 2, 3, 4, 5. Now the numbers are there, but you need to write in the mono, the di, the tri. You need to write those words in. So let's take that, the bottom of the top green page. I'm just taking the size, that's good. Now, I know we're running out of time, so let's get through this. We're only gonna tape in a couple more things, and then we will do all of this writing. We can do this one when we come back next week on Tuesday, okay? But while you're taping that in, we're gonna cut out those last 2 pages, so at least that way everything's put in, if that makes sense. And then we can come back, and the only part that I'm gonna work on with you is this top page, and then a little bit of the examples. The rest of the examples are for you to do. But we're gonna finish this cutting. So get your scissors, and let's grab this page with the lines. We're gonna cut that out, and it needs to fit on the second green page that says ionic covalent practice. I need to cut it so it can fit. So, now that I got it cut out, I'm gonna flip up the first green page where it says covalent ionic practice. It fits probably just barely snug in there. You might need to cut around the edges just a little bit more. But look, I'm able to fit it exactly in there. I mean, just barely. And I'm just gonna take the sides of it. I'm not gonna go like all around. I just take the 2 sides of it, and now I can go ahead and practice, and I can write those in, and just drill and kill practices. It's due, it has a due date. Remember, we do have to work on it. Now, the last paper, for those of you who are ready, has the drawings. If you're not, go ahead and keep taping and cutting that one out. If you can imagine, it's gonna go where it says degrees, shapes, drawings, polar, non-polar. So you need to cut it out so that way it can fit on that green sheet. So I'm gonna start cutting on my next one. If you're not ready, that's okay. Finish your page. Not only that, but if it makes sense, there are some really common drawings and names here that are used very often. So after practicing them a while, you might be like, oh, I saw that on the folder, or I saw that on the homework. So the last one, gonna go on that last green page. You kinda gotta cut it here so that way it fits it. For those of you who write gigantic, you're gonna have to write smaller. There we go. And just tape the 2 sides down, just a little bit of tape there, just to hold it in. When we come back, we're going to work on the one that says acids, and we're going to work on the top page that says naming. get your trash kind of like in a nice little pile, so it'll be easy for you to throw it away in just a moment. We can't leave just yet because we have to. Let's talk about the lab. We're gonna talk about it. That's it. We're not doing any more on the foldable. You do need it. If I was you, I'll probably start practicing and finishing some of this out because it is for a grade, right? But when we come back next week, we will work on the top page and we will work on the acid page, okay? Now, I'm going to move this to the back of the room, and I'm going to take my tape and scissors and put it back there. We need to go over, and it won't take long, your lab paper, okay? So you can get like a pen, a pencil, a highlighter out. I'm going to highlight what is mandatory to do. I'm going to put the foldable back here if you want to take a picture of it. I'm going to highlight what is mandatory that you have to do Friday, Saturday, Sunday, Monday. I mean, you've got 4 days. Okay, I've got the pictures for all of this stuff, just like we did last semester. Right, when I took pictures, I was like, okay, this is station number 1 or station number 2. I have all the pictures there for you. You've got to go look at the picture and answer them. So what you're going to do is you're going to highlight what is mandatory to do at home. So I already have it highlighted. I'm just going to say at home. This is not going to be in lab. We're not going to have time to do what's highlighted. Okay? This is mandatory for you to do at home. Ready, page 2? The bottom part. Okay? The bottom part. And there'll be different pictures. You click on the picture, and it's going to say station number 3. And it's going to say A, B, C, D, different cards. And you're going to go to that picture and look and see and do what you got to do. Page, again though, that is at home. We will not have time in class to do that. Turn to page 3. The top and the bottom part are going to be at home. Do them on Monday. I mean, I'm good with that. But it has to be done at home. If you've got some spare time in between your classes on Monday, do it then, Sunday.